Okay, Wildcats. Today we're looking at Tuesday, April 24th, operation of functions on page 77. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, operations of polynomials on page 77. Operations of polynomial steps. Step 1, composition of functions. Refer to page 10 for composition of function notes. Step 2, distribute. Step 3, combine like terms. Step 4, write in standard form. All right, if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, example 1. Perform the indicated operation. Identify any restrictions. Okay, don't forget to identify any restrictions. Okay. All right, so f plus g of x is f of x plus g of x. Okay, so we're simply adding the function f of x and g of x. So f of x is 2x squared plus 4x minus 6. And we're adding g of x, which is 2x minus 2. Okay, so there's no distribution, so we combine like terms. There's no 2x squareds. And I'm actually going to shade that out as we go through. Okay, so now we combine the 4x and the 2x, so that's plus 6x. And then negative 6 minus 2 combined is negative 8. Now, restrictions only apply if you have a denominator. There's no denominator, so there are no restrictions. Okay, example 2. So now we're doing f minus g of x. So that's f of x minus g of x. All right, so f of x is 2x squared plus 4x minus 6 minus 2x minus 2. Now, when you subtract a function, you want to put in parentheses because you remember you're subtracting all of it. Okay, so our next step is we're going to distribute, but let's go ahead and write 2x squared plus 4x minus 6 down first. All right, we're distributing a negative 1 to both terms. So negative 1 times 2x is negative 2x. And then negative 1 times negative 2 is a positive 2. Okay, so now we combine like terms. There's nothing to combine with 2x squared. Now we combine the x's. So 4x minus 2x is plus 2x. And then negative 6 plus 2 is a negative 4. There's no denominator, so there's no restrictions. Okay, so now let's look at example 3. G times f of x. So that's g of x times f of x. So g of x is 2x minus 2 times 2x squared plus 4x minus 6. Okay, so now we're going to FOIL. So 2x times 2x squared is 4x cubed. 2x times 4x is 8x squared. And then 2x times negative 6 is a negative 12x. Now we're going to multiply by negative 2. So negative 2 times 2x squared is negative 4x squared. Notice how I'm multiplying. I'm doing it, but I'm keeping things lined up. Okay, so negative 2 times 4 is negative 8x. And then negative 2 times negative 6 is a positive 12. So now we just combine terms through columns. So there's nothing to combine with 4x cubed. 8x squared minus 4x squared is positive 4x squared. And then negative 12x minus 8x is negative 20x. And then plus 12. There's no denominator, so there's no restrictions. Okay, so now we'll do example 4. So f divided by g of x. So that's f of x divided by g of x, which is f of x is 2x squared plus 4x minus 6, and then g of x is 2x minus 2. Now, since there is a denominator, there is a chance for restrictions, but we won't know until we complete the problem or simplify the problem. All right. So here, we're going to, I would think, factor that. So we can factor out a 2 from each of these terms. So that's 1x squared plus 2x minus 3 divided by, we can factor a 2 out of that, and that's x minus 1. All right, so the 2's divide out. Now we're going to factor this some more until we know 2 parentheses. We know x and x. And then we know x plus 3 and x minus 1. Okay, lining up with x minus 1. This divides out, so thus no restrictions. So we have x plus 3 with no restrictions. All right, so take a moment to finish up example 1 through 4. All right, so now let's take a look at example 5. All right, perform the indicated operation, identify any restrictions. All right, so we have f minus g of x. So that is f of x minus g of x. So f of x is x squared minus 4 minus g of x, which is x minus 2. Now, technically, there's a 1 in front of the parentheses that we're going to distribute. So then we have x squared minus 4, distribute the negative 1, that's minus 1x, and a plus 2. Now we combine terms. There's nothing to combine the 1x squared. Nothing to combine with the negative 1x. And then negative 4 plus 2 is a negative 2. There's no denominator, so there are no restrictions. All right, let's look at example 6. So we have g divided by f of x. So that's g of x divided by f of x. Now there is a denominator, so there's a chance for restrictions. So g of x is x minus 2 divided by f of x, which is x squared minus 4. Okay, so at this point, we want to factor. So that's x minus 2, nothing to factor there, but we know that x squared minus 4 is the difference of squares, so that's x minus 2 times x plus 2. Well, these divide and become 1, so you're left with 1 divided by x plus 2. We're left with the denominator, so we need to set that not equal to 0, because the denominator cannot be equal to 0, because a number divided by 0 is undefined. Okay? So a number divided by 0 is undefined. Okay, so when we do that, we subtract 2 from both sides. So we know that x cannot be negative 2. So x does not equal negative 2 is our restriction. All right, so now let's take a look at example 7. So we have g of x divided by h of x. So that's g of x divided by h of x. Now there is a denominator, so there is a chance for restrictions. So g of x is x minus 2. H of x is the square root of x plus 3. Now you can't have a radical in the denominator, so what we need to do is rewrite this as x minus 2 divided by parentheses x plus 3 to the 1/2. Now, in order to get rid of the radical from the denominator, we have to multiply the numerator and the denominator by the radical. And you can do that because anything divided by itself is 1. So really, we're only multiplying by 1. But what that does is, first off, that leaves x minus 2 times x plus 3 to the 1/2. But now when you multiply here, you add the exponent. So 1/2 plus 1/2 is 1, so you're left with x plus 3 to the 1 power. So you're going to take the 1/2 and bring it back to your radical. So then that's x minus 2 times the square root of x plus 3 divided by x plus 3. Now, you could argue that these answers are both the same, and I would probably accept both answers, okay? Now, at this point, we have a denominator, so we need to set x plus 3 not equal to 0. So x does not equal negative 3, and that's our restriction. All right. Well, got blurry there for a minute. All right. Example 8. So now we have g of x times k of x. Okay, so g of x is x minus 2 times k of x is 1 divided by x cubed minus 2x squared minus 9x plus 18. Now, at this point, we want to factor the denominator, so we're just left with x minus 2 in the numerator. So now, here, we can probably try factoring by grouping since it's 4 terms. We can factor out an x squared first, and we're left with x minus 2. Here we can factor out a negative 9, and we're left with x minus 2. So we can factor by grouping because these are the same. Looks like we need to add another line. Okay, so we have x minus 2 divided by x minus 2 times x squared minus 9. Okay, well, x squared minus 9 can be factored to be x minus 3, x plus 3. So, but before we do that, this divides and becomes 1. So we have 1 divided by x plus 3, x minus 3. All right. At that point, we see that our restrictions are going to be x does not equal -3, and x does not equal +3 are our restrictions. All right. So at this point, if you understood the examples, then start working on the assignment. Now, I'm going to be absent today, so I would recommend working on the assignment with a partner. Now, because I'm going to be absent, what I recommend doing is pausing the video, work through the assignment, and then come back to the video, and you can use the video to check the assignment. So I'm going to actually, in the video, show you all the answers to the assignment, so that way, since I'm going to be absent, you can check your work, okay? So pause, complete the assignment, and then once you got it completed, use this to check your work. All right, so I'm just going to leave them up, each sections of problems for a few seconds. So if you would check problems 1, 2, and 3. All right, now check problems 4, 5, and 6. All right, now check problems 7, 8, and 9. All right, now check problems 10. I think we can actually, can I fit them all in here? Yep, so go ahead and check problems 10 through 15. All right, now check problems 13 through 18. All right, so that should help you check your work. Since I'm going to be absent today, just turn in your assignment from Monday and Tuesday on Wednesday, April 25th. So with that, have a wonderful Wildcat